June 14, 1944. Dawn broke cold and gray over the hedgerows of Normandy, 8 days after the Allied invasion had torn open Hitler's Atlantic Wall. Through the morning mist that clung to the ancient bocage like a shroud, Obergefreiter Klaus Müller of the 12th SS Panzer Division crouched in a hastily dug foxhole, his hands trembling not from fear but from exhaustion, his eyes red-rimmed and hollow, fixed upon something that defied reason. Across the cratered field where yesterday's battle had left 3 American Sherman tanks burning, their hulls punctured, their treads shattered, their crews lost, those same mechanical corpses were moving again. Their engines growled to life. Their guns traversed with mechanical precision. Fresh white stars gleamed on their turrets. Müller rubbed his eyes, certain that hunger and sleeplessness had finally broken his mind. But the sound was real. The rumble of diesel engines, the clank of steel treads on stone, the impossible resurrection of machines that should have remained as twisted monuments to German superiority. He was not hallucinating. What Klaus Müller witnessed that morning represented something far more terrifying than American firepower or Allied numbers. He was watching the death of everything the Wehrmacht had believed about modern warfare, about industrial capacity, about the very nature of mechanized combat. For 4 years, German soldiers had been taught that their panzers were invincible, that their engineering was superior, that quality would always triumph over quantity. They had watched their Tiger and Panther tanks destroy American Shermans at ratios of 3-to-1, sometimes 5-to-1. They had seen the inadequacy of American armor, the way their 75mm shells bounced harmlessly off sloped German steel. They had taken comfort in this technical superiority, even as the strategic situation darkened. But now, in the hedgerows of Normandy, they were learning a harder truth. War was not won by the tank that could penetrate the most armor. It was won by the tank that could return to battle after being destroyed. The Sherman tank, derided by German tankers as a Ronson lighter because it lights first time, every time, was not designed to be the best tank on the battlefield. It was designed to be rebuilt. Its welded hull construction could be cut apart and rewelded in field conditions. Its interchangeable components meant that parts from 3 destroyed tanks could create 2 functioning ones. Its simple suspension system required no specialized tools to repair. Its engine, derived from commercial truck designs, could be swapped out in hours rather than days. The Sherman was not a weapon. It was a philosophy, an entire industrial system compressed into 30 tons of mobile steel, and behind it stood something that no German commander had adequately prepared for: the full unleashed capacity of American mass production, now transplanted directly onto the battlefield itself. The German way of war had been built upon different foundations. When a Panther tank threw a track in Normandy, it required specialized recovery vehicles, factory-trained mechanics, and spare parts manufactured in the Ruhr Valley. The tank would be towed to a rear area depot, sometimes dozens of kilometers from the front. There, if parts were available, and increasingly they were not, skilled craftsmen would spend days, sometimes weeks, restoring the vehicle to combat readiness. Each Panther was a precision instrument, a masterwork of German engineering with its interlocking road wheels, its complex transmission, its sophisticated fire control systems. But this precision came with a price. The Panther's overlapping road wheels, designed to distribute weight evenly, would freeze solid in winter, packed with mud and ice. A single damaged wheel required removing up to 8 others to replace. The transmission, pushed beyond its design limits by the tank's excessive weight, failed with brutal regularity. And when these failures occurred in combat, German crews had 2 choices: effect repairs under fire or abandon their vehicle to the enemy. The Americans, by contrast, had brought the factory to France. In the weeks following D-Day, US Army ordnance units established what they called mobile maintenance shops, a clinical term that failed to capture the industrial miracle they represented. These were not mere repair stations. They were complete manufacturing facilities on wheels, capable of operations that would have required a stationary factory in any previous war. Each armored division traveled with its own maintenance battalion, over 500 men organized into recovery companies, maintenance companies, and specialized platoons equipped with everything from welding equipment to precision lathes. Behind them came the separate tank destroyer and tank battalions, each with their own organic maintenance units. And supporting all of these were the Army-level ordnance depots, massive logistics nodes that could rebuild entire tank battalions from scratch. The system worked with assembly line efficiency. When a Sherman was disabled in combat, forward observers, often the tank crew themselves if they survived, radioed its location to battalion headquarters. Within hours, M32 tank recovery vehicles arrived at the site. These were Shermans with their turrets removed and replaced with cranes and winches, capable of towing a disabled tank at speeds up to 20 miles per hour. The M32 crews worked under fire, often advancing ahead of infantry to retrieve damaged vehicles before German forces could destroy them completely. They hooked chains to tow rings, fired up their winches, and dragged the wounded machines back to collection points just behind the lines. Speed mattered more than safety. Every hour a tank spent in no man's land was an hour the enemy could use to demolish it beyond repair. At the collection points, mechanics performed triage with the dispassion of field surgeons. Tanks with minor damage, thrown tracks, damaged road wheels, non-penetrating hits, were repaired on site and returned to their units within hours. Those requiring more extensive work were sorted by the nature of their injuries. Vehicles with engine damage went to powertrain specialists. Those with turret damage went to armament experts. Tanks with hull penetrations were dragged to welding stations where acetylene torches blazed through the night. The work continued around the clock under blackout conditions, the mechanics guided by hooded lights and the muscle memory of men who had performed these operations hundreds of times in training. There was no discussion of whether a repair was possible. The only question was how quickly it could be completed. For truly catastrophic damage, tanks that had burned, that had ammunition explosions, that had been struck multiple times by German 80mm guns, the Americans had developed an approach that would have been unthinkable to German doctrine. They practiced what ordnance manuals called salvage and reclamation, but what the mechanics themselves called Frankenstein work. 3 destroyed tanks would be systematically cannibalized, their salvageable components harvested like organs from donors. A turret from one wreck would be mated to the hull of another. Engines, transmissions, final drives, anything that still functioned, was removed and cataloged. The result was that tank losses became merely mathematical problems. 3 total losses could become 2 functioning tanks and a pile of scrap metal in less than 48 hours. The industrial line between destruction and creation had been erased. The Germans watched this resurrection operation with growing horror. Oberst Heinrich von Luttwitz, commanding elements of the 2nd Panzer Division, wrote in his post-battle report, "The enemy's tank repair capability exceeds anything in our experience. Vehicles we confirmed destroyed are returned to combat before our own lightly damaged tanks can be recovered. This creates the psychological impression of facing an endless enemy, an adversary whose strength is not diminished by our tactical victories." What von Luttwitz had identified, though he lacked the language to describe it, was the collision between 2 incompatible theories of industrial warfare. Germany had built an army that treated tanks as valuable assets to be preserved. America had built an army that treated tanks as expendable ammunition to be expended. The philosophy extended to every level of the American system. Sherman tanks were shipped to Normandy, not merely as complete vehicles but as containerized component sets. A single Liberty ship might carry 50 complete powertrains, 100 replacement turrets, thousands of road wheels and bogies, all pre-positioned and cataloged. Army supply depots in England maintained what accountants called float stocks, reserve inventories large enough to replace every Sherman in theater simultaneously. When a tank was damaged beyond field repair, it was not sent to England for depot-level maintenance. It was simply abandoned, its serial number recorded and struck from inventory, while a fresh vehicle was drawn from stocks and assigned the same unit designation. The individual tank did not matter. Only the maintenance of unit strength mattered. To support this industrial machine, the United States had performed the logistical equivalent of moving Pittsburgh to France. In the months following D-Day, over 30,000 ordnance personnel landed in Normandy, equipped with more than 15,000 individual pieces of repair equipment. These ranged from simple tools, wrenches, hammers, jacks, to sophisticated devices transported across the Atlantic at enormous cost. Mobile machine shops carried engine lathes capable of precision work to within 1,000th of an inch. Portable forges could heat-treat replacement parts to restore their original metallurgical properties. Welding trucks carried both electric arc welders for structural repairs and oxyacetylene equipment for cutting and brazing. There were wheel presses for removing and installing road wheels, spring compressors for suspension work, battery chargers, paint sprayers, steam cleaners, and specialized hoists. Each maintenance battalion operated as a fully mobile industrial complex, capable of performing operations that most nations could only accomplish in permanent facilities. The Germans had nothing comparable. Their maintenance system, designed for the methodical warfare of 1939 and 1940, had been stretched past collapse by the demands of fighting across thousands of miles of Russian steppe. Their repair depots were stationary facilities, vulnerable to air attack and increasingly isolated by the destruction of rail networks. Their recovery vehicles, in chronic short supply, lacked the speed and power to keep pace with American M32s. Most critically, they lacked the industrial base to sustain losses. When a Panther's transmission failed, a replacement had to be manufactured in Germany, shipped by rail to France if the rail still existed, and then trucked forward through roads under constant Allied air attack. The journey took weeks when time was measured in days. By war's end, German units were reporting that more tanks had been lost to mechanical failure and abandonment than to enemy action. But the American advantage extended beyond mere logistics. It was cultural, embedded in the very DNA of industrial democracy. The mechanics who rebuilt Sherman tanks in Normandy fields were not professional soldiers. They were farm boys who had grown up repairing tractors, factory workers who had assembled automobiles in Detroit, garage mechanics who had kept America's commercial fleet running through the Depression. They approached tank maintenance not with Prussian precision but with American pragmatism. If a part did not fit exactly, they made it fit. If a procedure manual said a repair required 12 hours, they found ways to do it in 6. They improvised, adapted, invented solutions that no engineering manual had considered. When they ran out of official repair parts, they manufactured replacements on their portable lathes. When they lacked proper welding rod, they cut salvaged steel into strips and used that instead. The American genius was not in following rules, but in knowing which rules could be broken. This improvisational culture extended to tactical innovation. When mechanics discovered that Sherman hulls damaged by German 8mm guns could not always be welded successfully, the hardened steel resisted fusion. They developed patch techniques using softer steel plate bolted over the damage. When they found that turret bearings exposed to Normandy mud wore out faster than replacement parts arrived, they invented field expedients using captured German grease and modified seals. Every problem spawned a solution, and every solution was communicated informally through the network of mechanics. Technical bulletins from Ordnance Headquarters often documented procedures that had been invented and perfected in the field weeks earlier. The Army's rigid hierarchy dissolved under the pressure of necessity, replaced by a meritocracy where the man with the best idea, regardless of rank, saw his innovation adopted fleet-wide. The symbolic heart of this system, seen repeatedly in photographs from Normandy, was the wrench. Not the specialized torque wrench of German precision engineering, but the American adjustable wrench, that crude, simple tool that could be adapted to fit almost any nut or bolt. In the hands of American mechanics, the adjustable wrench became a philosophy. It represented flexibility over perfection, adequacy over excellence, getting the job done over getting it exactly right. German engineers had designed their tanks with specialized tools for every operation, each machined to precise tolerances, each irreplaceable. American engineers had designed the Sherman to be maintained with a basic tool set that could be purchased at any hardware store. When German mechanics lost their specialized wrenches, they could not complete repairs. When American mechanics lost theirs, they borrowed from the motor pool. Klaus Müller, watching those resurrected Shermans rumble past his position on June 14th, did not understand these systemic differences. He could not comprehend that he was witnessing the end of one industrial age and the beginning of another. He knew only what his eyes showed him, that the Americans possessed some dark industrial magic, some capacity to reverse death itself. In his diary, recovered after his capture 2 weeks later, he wrote, "They do not fight like soldiers but like factory workers, treating war as if it were merely another form of production. Their tanks are not weapons but products, and products can always be manufactured again. How do we fight an enemy who accepts destruction as part of the process, who has made peace with loss before the battle even begins? His question contained an answer he could not fully articulate. The American way of war in Normandy was not built upon martial virtue or tactical excellence. It was built upon acceptance of terrible arithmetic. American commanders knew that Sherman tanks were inferior to German Panthers and Tigers in almost every technical specification. They knew that American crews would die in burning Shermans, their bodies charred beyond recognition, their families receiving telegrams that offered no comfort. They accepted these casualties because they had done the mathematics and understood that industrial capacity could compensate for technical inferiority. For every Sherman destroyed, 3 more would land at Utah Beach. For every crew killed, replacement soldiers trained in Georgia and Texas would take their place. The system was not humane. It was not even particularly efficient by pre-war standards, but it was unstoppable. The German response to this industrial onslaught revealed the fundamental bankruptcy of their own system. As the Bocage battles ground through June and into July, Wehrmacht maintenance units attempted to match American recovery and repair rates. They failed comprehensively. German repair depots, already undermanned and undersupplied, collapsed under the strain of catastrophic losses. Disabled panzers were abandoned in place, their crews ordered to demolish them with explosives rather than leave them for American recovery. This self-destructive policy ensured that the German tank force could only shrink, never regenerate. By August, some panzer divisions reported operational readiness rates below 20%, not because their tanks had been destroyed in combat, but because they lacked the parts and expertise to repair battle damage. In contrast, American armored divisions maintained readiness rates above 70% throughout the Normandy campaign. This was not because Shermans were more reliable than German tanks. Mechanical failure rates were actually comparable. The difference lay entirely in the speed and efficiency of repairs. A Sherman with a thrown track would be back in action within hours. A Panther with the same problem might be out of service for days if it could be repaired at all. Compound this across hundreds of vehicles and thousands of mechanical failures, and the arithmetic became decisive. The Americans did not win because their tanks were better. They won because their tanks could be rapidly restored to mediocrity, while German tanks slowly degraded toward uselessness. The mobile maintenance system had another, less tangible effect. It transformed American tank crews' relationship with fear. German tankers, knowing that a catastrophic hit meant death or capture, that their vehicle could not be replaced, that their comrades had no way to rescue them under fire, fought with the desperation of men who had no second chances. American crews, by contrast, knew that damaged tanks would be recovered, that even if their vehicle was destroyed they would be assigned a new one, that the system would not abandon them. This knowledge did not eliminate fear, nothing could do that, but it transformed fear's nature. American tankers did not fight with Germanic stoicism. They fought with the confidence of men backed by overwhelming material support. When a Sherman was hit and its crew bailed out, they knew that somewhere behind the lines, mechanics were already preparing the replacement that would take its place. The maintenance system revealed itself in unexpected ways. Correspondents following the Allied advance noted a peculiar phenomenon. American tank graveyards were always temporary. Fields that had been littered with destroyed Shermans would be empty within days. Every salvageable hulk recovered and shipped to repair facilities. German tank graveyards, by contrast, became permanent. Without fuel to run recovery vehicles, without spare parts to effect repairs, without the industrial infrastructure to reclaim damaged machines, the Wehrmacht simply left their dead where they fell. These abandoned panzers became landmarks, navigation points for Allied units. Turn left at the burned-out Tiger. Rally point is the 3 Panthers near the church. Each abandoned tank represented not just a tactical loss but a strategic defeat, thousands of man-hours of skilled labor, irreplaceable raw materials, complex components that could never be manufactured again. By late summer, as Allied forces broke out of Normandy and raced across France, the maintenance system demonstrated its ultimate capability. American armored divisions advancing hundreds of miles in days brought their entire repair infrastructure with them. Maintenance battalions leapfrogged forward, establishing new collection points every 20 miles, ensuring that the distance between disabled tanks and repair facilities never exceeded recovery vehicle range. German units, retreating in disorder, abandoned even lightly damaged vehicles because they lacked the fuel to tow them and the parts to fix them. French civilians watching American tank columns thunder past noticed something strange. Many of the vehicles bore fresh welds on their hulls, new paint on their turrets, mismatched road wheels and track links. These were yesterday's casualties, today's combatants. Their deaths and resurrections compressed into a cycle measured in hours rather than weeks. The wrench, that humble adjustable tool, became something more than metal and utility. It became the symbol of American abundance translated into military capability. Where German soldiers carried photographs of families or loved ones, American mechanics often kept a worn adjustable wrench as their personal talisman, not because it held sentimental value, but because it represented something essential about their nation's approach to war. The belief that any problem could be solved with enough resources and practical ingenuity, that perfection mattered less than persistence, that getting machines running mattered more than getting them exactly right. The wrench did not aspire to elegance. It aspired to adequacy, and in adequacy repeated across millions of maintenance actions lay victory. As the war ground toward its conclusion, the full scale of the maintenance differential became statistically undeniable. American ordnance units in the European theater repaired and returned to service over 70,000 armored vehicles, tanks, tank destroyers, armored cars, half-tracks, between June 1944 and May 1945. This number exceeded the total production of German armored vehicles during the same period by a factor of nearly 10 to 1. The Germans had not been defeated by superior tanks. They had been defeated by superior repair capacity, by an industrial system so robust that it could treat catastrophic damage as a temporary inconvenience, by a military culture that had fused the factory floor with the battlefield until they became indistinguishable. In the end, Klaus Müller's question, "How do you fight an enemy who has made peace with loss?" contained no answer the Wehrmacht could implement. Their army had been built upon the premise that quality and will could overcome material disadvantage, that superior equipment operated by ideologically committed soldiers would triumph over numerically superior but technically inferior forces. This had proven true in 1939 and 1940, when opponents lacked the industrial capacity to absorb losses. But America possessed something that no previous German adversary had commanded: the ability to treat war as mass production, to accept destruction as a cost of business, to rebuild faster than the enemy could destroy. The mobile maintenance shops of Normandy were not merely support units. They were the physical manifestation of industrial democracy, of a system that valued function over form, results over purity, pragmatic victory over aesthetic defeat. On the morning of June 14, 1944, when Klaus Müller watched those resurrected Sherman tanks rumble past his foxhole, he witnessed more than a tactical surprise. He saw the future of warfare, a future where victory belonged not to the side with the best weapons but to the side with the most efficient repair schedules. The age of the craftsman warrior, of the perfectly engineered machine operated by a racial elite, was dying in the mud of Normandy. Rising in its place was something more terrible and more mundane: the age of the maintenance manual, the spare parts inventory, the round-the-clock shift work that turned destruction into mere data points in a production quota. The Americans had not brought a better army to Europe. They had brought a better factory, and they had placed it on wheels, and they had aimed it at the heart of a nation that still believed war was about glory rather than arithmetic. The wrenches turned. The engines roared to life. The resurrection continued, tank by tank, until there were no more German soldiers left to count them.